the graph of the change of the displacement of the spring in time. And the equation of this graph is x of t equals to the amplitude times the cosine of one number, and we call omega to that number, which is the frequency, times t minus the displacement in t, which is 0 in this case, plus the displacement in x, which is 0 in this case. And so the equation of this graph is x of t equals to the amplitude times the cosine of omega times t. And we know that the force is equals to minus the constant of the spring times the displacement. And the force is equals to the mass times the acceleration equals to minus the constant of the spring times the displacement. And the acceleration also is equals to the second derivative of the position. And this is a differential equation because have one derivative. And the solution of a differential equation is a set of functions or a class of functions. And this x is equals to this x, and this is equals to the second derivative of this. And so the first derivative of this is equals to the derivative of the amplitude, which is the amplitude because one constant, times the derivative of the cosine, which is minus sine of omega t, times the derivative of this, which is omega, and the second derivative of the position is equal to the derivative of minus the amplitude, which is minus the amplitude, times the derivative of omega, which is omega, because both are constant, times the derivative of the sine, which is cosine of omega times t, times the derivative of this, which is omega. And so we plug this here and this here, and so the mass times minus the amplitude times omega squared times the cosine of omega t is equal to minus the constant of the spring times the amplitude times the cosine of omega t. And the minus can be cancelled, and the amplitude also can be cancelled, and the cosine of omega times t can be cancelled. And so we have the mass times omega squared is equal to the constant of the spring, and omega squared is equal to the constant of the spring over the mass. And so omega is equal to the root of the constant of the spring over the mass. And now we plug this here, and so x of t is equals to the amplitude times the cosine of omega, which is the root of the constant of the spring over the mass times t. And when the cosine of the root of the constant of the spring over the mass times t is equals to 1, x of t is equals to the amplitude. And this is true when the root of the constant of the spring over the mass times t is equals to 0 or 2 pi or 4 pi. And so the root of the constant of the spring over the mass times t is equals to 2 pi. And so t is equals to 2 pi over the root of the constant of the spring over the root of the mass. And so t is equals to 2 pi times the root of the mass over the root of the constant of the spring. And of the mass over the constant of the spring, and this is equal to the period, and we know that the frequency is equal to 1 over the period, and so the frequency is equal to 1 over 2 pi times the root of the mass over the root of the constant of the spring, and so the frequency is equal to 1 over 2 pi times the root of the constant of the spring over the root of the mass, and so the frequency is equal to 1 over 2 pi times the root of the constant of the spring over the mass, and so the period is equal to 2 pi times the root of the mass over the constant of the spring, and the frequency is equal to 1 over 2 pi times the root of the constant of the spring over the mass. We see in the next video.